multiplying and dividing functions. And it is using function notation, so that does kind of funk with you a little bit. You know, you've got f plus g of x. And most kids know what that means. When I was taught, you know, this stuff way back in 1993, 94, and so forth, it was given to us as f of x plus g of x, which I think makes more sense. I really do think that makes more sense. But I still think of it in terms of that to this day. Just like you guys are taught CalcA, right? I was taught some old horse coming to the horse taking off away. It took me years to get that out of my head and just absolutely. Anyway, I still think of it like that. I think that makes more sense. What is it telling us to do with these two pieces, or these two functions? Literally do what? Add them. And unless you're that kid who doesn't understand like terms, I'm going to put a plus symbol here, right? Because I'm adding this stuff to that. Unless you're a kid who just doesn't understand like terms, that's the answer, isn't it? I mean, that's how hard this is. The ones you're going to have the most difficulty on are going to be subtraction, because you're going to have to get the distributive negative, and maybe division. Okay, they're not going to be too hard. Now, anybody any questions on that before I move on? Next one's f take away g of x. What's it telling us to do between the two functions? Subtract. And this will be the one where some kids have a mistake. Most kids are not. If you made it this far, you can do most of this stuff in your head. But if you're going to leave yourself a paper trail, that's two terms. What should you do? Wrap it. If you're doing a paper trail, you need to wrap. What's going to happen to both those signs, the negative 2x squared and the positive x? They're going to change. Again, I'm just showing a paper trail. I'm not saying you have to. See any like terms? What's your answer? 3x squared minus x. And the vast majority of you are going to be able to sit there and do this lesson in your head. You're really not going to have to write anything down. So you'll fly right through it. But, you know, there's always a handful of kids who are pretty weak on function notation. That's the only reason we're doing it. Reinforced function notation. Here we got something. F times g of x. What is it saying we do with f of x and g of x? Multiplying, right? Pay attention to order too, by the way. Order doesn't matter. Take a negative 2x and multiply by 4x plus 2. What property are you going to use? The distributive property. So what's our negative 2x times 4x? Negative 8x squared. Keep going. Minus 4x. So how's it going so far? Bored yet? Or you like it nice and easy like this? Everybody likes these usually. All right, next operation. I think I see f over g. So it's a division operation. Now, these are the ones, and thankfully, if you just don't miss anything, you don't have to do many of these. That's the key. Don't miss much. Don't miss anything. You don't have to do a lot of questions. These are the ones that are going to require a little bit of work. When they talk about simplest form, they mean factor everything. That's what they mean. Factor everything. Reduce everything you can reduce. So factor everything and reduce. Now, that 2x squared really can't be factored. You could say it's 2 times x squared, but that's already implied. We're just going to leave it alone for now. Anyway, I'll do the initial setup, by the way. That's the initial setup, right? Now, do you see anything that can be factored? All right, Taylor says everything's divisible by 2. Do you agree with that? And remember, it's about all pieces. All 3 pieces, not just those 2 or those 2. It's about everything. Otherwise, you kill what? Kittens. A couple of you may look at that mean. Every single thing in here is divisible by 2. So Taylor's suggestion was to start there. That's a good suggestion. Do you see anything else that can still be factored? We'll have 2 on the bottom. I don't know that IXL is going to care if you pull out the positive 2 or the negative 2. When I did this one, I pulled out a negative 2 and accepted the answer. I don't think it's going to care. I wish I could pull up this exact question and check. I'm just telling you, when I did it, I pulled out a negative 2. And it said, great job. So I felt good about myself. So what I'm going to do is I'm going to pull that negative 2. Because I know that worked. If I pull a negative 2 from negative 2x, what remains? X, right? If I pull a negative 2 from a positive 2, what remains? What? Negative 1. Now that is as simple as this thing gets. That is what goes in the first box. What's that second box talking about? What x can't be. And there's a simple rule for what x can't be. Thou shalt not divide by what? 0. If God was a math teacher, that's how he'd say it. Thou shalt not divide by 0. So I wish I had some free space. Let me enter our page here. We have what, x squared over negative 2 times x minus 1. Now, not every kid in this world can see what's going on. If you know you can't divide by 0, we'll write that down. You know you cannot divide by 0. So write a statement. That says the denominator is not 0. You know you can't divide by 0. Write a statement that says you can't be 0 in the denominator. That's in words. You don't need words, you don't like words. What's a statement that says the denominator can't be 0? What's that? That's not kind of what I mean, Haley. You're pretty good at this. You already knew the answer. There are a handful of kids in here who really struggle with this. Yeah, I'm going to say the bottom is not 0. The goal here is to figure out what x cannot be. So I'm going to say the bottom can't be 0 because thou shalt not divide by 0. And here's how Haley got her answer. Wait a minute. It basically says x minus 1 is not 0, right? So what is x not? 1. There's your rank, give your lines over there. Anybody any questions? No. Nobody ever does. You know what question I get asked most every single day? What is the question that I get asked most every single day? Can I go to the bathroom? Let's see, what's the goal of this one? What is f over g of x? And I must have cut off the answer blank here because on the division ones, you are going to have to state what x cannot be. On all the division ones. You see division, it's going to have a little secondary box that says x can't be what? Doing concepts of domain here. So the setup on this one's pretty easy. You just throw 3x plus 3 over what? Over x, that's right. IXL is going to reject that thing. It's the simplest form. They are after factor form, and there's a reason that they're thinking along those lines. And that's doing actually start looking at graphs and thinking about rational functions. How about factor of the numerator? Oh, 3. It's commandment 1. If you can pull it, pull it. Everybody should be able to factor that. So there's the answer that goes in the first box. I don't even know that we need to write a statement for this. I mean, kids, Bryce for that matter, what can x not be? 0. Does everybody see that x can't be 0? If it was, the world's over. Why don't you guys do that one? Checking at the office. Are you keeping a folder in here? Well, I didn't get to walk around and see everybody's work, but Lindsay, how'd you set it up? Okay, so 5x plus 1, negative 5x. Anybody try to do anything on that? Some of you tried. Is there really anything you could do? You could probably divide both the top pieces by the negative and make the bottom negative. IXL is going to accept that because there's not really any factoring. There's no factoring. Now, I did notice that a handful of you guys missed what x could be. So let's go over it. Maybe you didn't write it down. Maybe you just kind of thought there was something on the other side of equal than 1. What do you say that bottom negative 5x cannot be? Cannot be 0. You can also say equals 0 if you want. What do you divide out? Divide that negative 5. Lauren, after Williams, what'd you come up with, Lauren? You get it. What's 0 divided by negative 5? 0. In your head, you thought there was a 1 over there. That's what happened to you. I know you didn't get it. I was curious if you figured it out. And looking by the number of people writing things down, a lot of people didn't figure it out. It's really as simple as taking the bottom and saying it's not what? 0. But you need to say it, okay? Just say that. Write a statement. Or think of the statement in your head. Oh, we've still got a little more multiplication to do. I think that's the hardest one in there. Seems like there was some division. The division started showing up pretty heavily in the 70 to 80 range. we've got this guy in front of us. And this guy actually presents a lot of things we can do. If we do the initial setup, make 3x squared plus 3 over x squared minus 4x. Do you see factoring opportunities? You see anything up top in the numerator? What do you see up top in the numerator? Yeah, pull that negative here too. I'm a big fan of pulling a negative. There's a reason I'm a big fan of pulling a negative, because it's usually the right step. I'll pull that negative 3, what remains? X squared minus 1. We'll go back to that numerator in just a minute. What do you see in the denominator? What's that, Bryce? Bryce is pulling x. Both pieces have an x. Pull it. X times what? X minus 4? Can you tell me what x can't be?
4.
4 is one of them. 0. No, write that statement and just cover up. That says x is not 0. That says x minus 4 is not 0. X is not 0, and x is not negative 4. This answer is going to be rejected, though. Why, Britain? Oh, yeah, sorry. That's me screwing off. Sorry about that. But the actual expression you wrote will be rejected. Why will the expression you wrote be rejected? Now, there's nothing wrong with the denominator. Let's go back. You saw x squared minus 4, that's how you factor it. It's not that the top has an x squared. It's that when simplest is mentioned, you are supposed to factor. You are not done factoring, kids. You're not done factoring. This is why I said formula quizzes need to be shown back up. How does a squared minus b squared factor? There's a difference to squares sitting in the numerator. X squared is literally an x squared, and 1 is a 1 that is what? Squared. So back to the top. How does that x squared minus 1 factor? X plus 1 times x minus 1. Well, I know you did a whole bunch of IXL on factoring difference to squares. I know you did. I know you did a whole bunch of IXL on difference to cubes and sum of 2 cubes. You have to remember stuff, kids. You can't just move on to the next day and open your eyes and hope it's a new day and math will just true. That's the answer we'll take. Oddly enough, the more complex multiplication didn't show up until the late 80s when I did this thing. And I say this is more complex multiplication because both pieces have 2 terms. It is x times 2. It's a negative x plus 1. You can rewrite that if you want. You can write that as 1 minus x if you'd like to. Personally, I do. But I show that year after year and nobody ever wants to do things the way I do, so I'm not going to bother. So when I see stuff like this, what would Jesus, which is what would Jesus do, right? What? So why don't you pull that out real quick? Been a minute since I've seen you on foil. Draw the stupid arrows. Remember, once you're done, you can always combine all terms. And I appreciate the fact that you did that. There's no need to do it. Simplest factoring one of those fractions. Looks like this half the room's more or less got it. I'll assume that half the room has it. Alright, so I saw you guys do this. That's your negative x cubed. I saw you do that. That's a plus 9x. I saw you do that. Plus an x squared. I saw you do that. Minus a 9x. Perhaps I screwed up somewhere, haven't I? That's a squared. Maybe I said that and didn't do it. I don't know. Anyways, when you combine like terms, it's the x squareds that you got to put together. How many are there? 10. Negative x cubed plus 10x squared minus 9x. Now it does say simplest form. That just, in this, on the multiplication ones, that just means combine like terms. That's all it means. It doesn't mean factor. Erin pulled an x out, and she did it right, but he didn't have to. We're only on page 5.
That's a negative 9x. That's a negative 9x. Now that's negative 8.
No. No, it's, she sees this. Oh, that's the eraser. Let me redo that. And I know what you're looking at, Emily. But this, she's looking at, and I don't think she's probably not the only one. She's looking at this guy and that guy, right, Emily?
Yeah.
What's the?
I guess I missed. Whenever I multiplied the negative 9 times by 1, I put it at, what did I do? Hold on. I don't know, I put a negative in there somewhere, so I got a negative.
I assume that you tried to put x squared and negative 9x, but I don't know, I may not. You're right. This is as hard as it gets. I actually did not see this question until I got to like 99. I don't know if you're going to take it to 100 or not, but somebody might. So here we go. This is the one that got me to the 100. So it's f over g again. Looks like there's two things x can't be. We were doing worksheets in this class. This is, most of your homework can look like this stuff. My issue with Excel, it's too weak.
Mr. Milbrath?
Yes, ma'am.
You did the answer.
I never hit submit, did I?
That's okay.
Sean out and Kelly Warren.
Sean Duddy?
No, Sean.
Coy.
Yeah, Coy.
All right, thank you.
What can you do with numerator? Back out 2. Here. Is it bottom factor? Yeah, it's factors. What's take to create that 3x squared? That's how you start. Let's take to create this piece. X and x. And then the last thing you worry about creating is the last piece, and you just think by order. Let's take to create 2. 1 and 2. We'll try 1 and 2. You can kind of guess and check here. That's 6. That's x. And you think, yeah, you get the 6. You can get 5x with that, can't you? Maybe you make this one negative and that one positive. Does that actually work out? Because a negative 1 times positive 2 is a negative 2. So that's how it happened. I did not see any situation where you had cancellations happen between the numerator and denominator. I'm not saying they're not there, I'm just saying I didn't see them. Only thing we have left to answer is domain, what can x not be? Taylor says -2. You got that right here. Remember you change sign and make parentheses. What about the other one? 1/3. 3x minus 1 can also not be 0. And some kids are going to struggle with that. So 3x is not 1, and x is not 1/3. And that was a 99-point question. Most of y'all are going to stop at 90. Handful of y'all keep going. Yeah, sorry, 95. And the last thing is composition of functions. And IXL really makes these easy. Now, I have how you're supposed to read this stuff in your head. A mathematician, hopefully a student, would read f of x as f is a function composed of x's. F is a function composed of x's. Like if I say f of x equals 3x squared plus 4, is that not composed of x's? Is it not made up from x's? We're referring to the stuff in the parentheses as a variable. How would you read f composed or f of x minus 4? F is a function made of what? X minus 4s. You can say made of or instead of composed. Made of x minus 4s. Like you might have some weird function, f of x equals x minus 4 squared minus x minus 4 plus 2. All those things kind of in the variable spots are just x minus 4s. And if you're still reading like f parentheses x's, that's how you're reading it. That's the problem. This is your second year with me. I've always said f of x. F of. How would you read f of g of x? What does that mean? It means f is a function composed of a function called g of x. I'm not going to write it down. It's kind of long. But f is a function composed of another function called g of x. Kind of funny looking. That's what we're doing today. We're seeding another function. We're seeding a function with another function. And IXL doesn't go in too deep on this stuff, so like you don't have to know anything about domain because they never do any division. They just have this. I was helping a dual enrollment kid with this the other day, and they still weren't paying attention when I taught this to them last year. They saw a notation like this. I didn't know what to do. Now, this is equivalent to that. They are equivalent statements, just different notation. Now notice what's happening here. The fact that that's inside says replace variable in f of x with g of x. That's all it's saying you do. I mean, you know that because if you saw something that said f of 4, you would replace x with a 4. You already know what's going on. It's just saying do replacement. So f of x is 6x and g of x is 3x plus 6. All this is telling us to do is take that piece and put it right there. You guys get that? Don't forget if it's 2 or more, so you better route. That's really not the only thing you can do wrong is forget to route. Even if you're doing it mentally, you got to remember you got to use the distributive property on that. What is 6 times 3x plus 6?
18.
Sounds right to me, Taylor. The distributive property, she came up with 18x plus 36. There is no need to factor. They just want you to combine like terms. That's what it means on the multiplication. Put your like terms together. Now, when we do the second one, what are we going to replace this x with? 6x. So here's what someone will do. And I know you will. Someone, if I can get this thing out of exponent space. There we go. Someone will say 6x squared plus 6. At least one of you in here will do that. And IXL will tell you incorrect, won't it? Why? Why is it incorrect? Yeah, we gotta do an error analysis here. We have to square both pieces. There we go. You know what you were supposed to do is you were supposed to square both pieces of that thing. What were you supposed to have as an answer? I always wonder if pointing out common student mistakes doesn't make them make the mistake. But that's a common mistake, and somebody here will do it. I'll never know because I'm not actually grading your homework, but somebody's going to do it. We are almost done. How many we got left? 2, 3 examples. Why don't you guys do this one right here? The next example you see. And then I'll do an easy one and give you one slightly harder. I know kids who miss every single question. They're still confident. I haven't figured out why, but at that point, you should be questioning your confidence. Well, let's say about 8 out of 5. Well, 8 out of 5. That makes perfect sense. About 8 out of 10 is what I was trying to say. About 8 out of 10, 4 out of 5 got it right. 80%. Well, everywhere I see an X, that piece goes in. When I did this one in my head, I actually went back because I got an answer that's kind of funny to me, so I went back and double checked it. I got in the habit of squaring the first piece and I tried to square the second piece for some reason. You gotta be careful with things like that. When you do something, you kind of want to do it again. Or maybe you want to drop a piece. And it does help to write things down. Now, when you square this piece, because you gotta remember PEMDAS, right? Please excuse my dear Aunt Sally, which is apparently, I don't know why I never taught it like this. Please execute, my dear Aunt Sally. It sounds so much more fun. Please execute, my dear Aunt Sally. Are we supposed to handle this exponent first? What's the 5x times 5x? There we go. Now everybody can do the last piece. It's 4 times 5x. 20x. So what is that 3 times that 25? 75 in the x squared. Hopefully those of you that missed it figured it out. I'm going to do this nice easy one, unless y'all do the last example. This one's going both ways. It wants both f of g, and it wants g of f. It seems like these showed up around 80 points, maybe. I could be wrong about that. So when we find f of g of x, everywhere I see an x in f, what am I going to replace it with? G, 4x minus 8. Actually pretty simple. I replaced the x with 4x minus 8, and I didn't forget there was also a plus 7. It's just about combining my terms, isn't it? So what is 4x minus 8 plus 7? Four x minus 1. And that goes in that box. Now the other one's the other way around. It's g made of f. So pay attention to that. G made from f. If I do g made from f, I take the x plus 7 and I throw it right in there. And before you worry about the 7 and the 8, what has to be handled? Distributive property. Everybody can do the distributive property. That's going to be 4x plus 28, and then take away an 8. My final answer is 4x plus 20. So I did the nice easy one, so you guys do the hard one. I think, I didn't finish this one, but I think the hard one showed up right around 95, 96. I scanned through to see if there's anything harder than that. I couldn't find anything, so I stopped. You are finding both. I just left the answer myself there. You read instructions, find f of g and g of f. this different with this?
Yeah.
There's nothing to do with it. Only factor in the division. Only factor in the division. You just press it. I don't know that I saw it separate, to be honest with you. I never thought of it. Okay, my little Satanists in here. Yeah, set it up right. But then I wrote this. Something along those lines. All you did was first and last. That's all you did. That's not how you do this. If something's squared, how many times is it written? Twice. You gotta write twice. I am joking with you. I don't believe you worship Satan. But you know what? If you do, I'm still not gonna hate on you. Write it twice, kids. Write it twice as well. You can't just apply it. You can apply the exponent to both pieces of multiplication. You cannot do it with addition or subtraction. Okay, for multiplication and division, not addition and subtraction. Anyways, after you follow that, you get 36x squared minus 18x. Oh, that's wrong. Minus 36x plus 9. I saw a couple of you stare at the next one for a second, like, is it really that easy? But you kind of stared at g of f of x. Well, that's just simple as putting an x squared here, isn't it? Really is. So again, let's try not to kill kittens. Please, start forming.
Would it look like
Plus 9, isn't it?
we'll pull it out? Pull out the 9.
No. Of course, y'all are doing this. I saw Asia write this down. Maybe I should only factor when dividing. Oh. Well, I had only in factoring, I didn't I? Left off the y and put the f in. I will probably teach tomorrow. The stuff I've done is not that hard. You can probably take both of those out in 15 minutes if you know what you're doing. But if I give you guys 2 work days in a row, a couple of you have nothing to do, and that's not good. You always got to have a little something to do. Yes, you're doing. What's that, Emily? You're dropping out. For those of you watching at home, Emily is dropping out.